Welcome to Mr. Lamb Science Corner. We've got a kind of an exciting one today. It really doesn't match. It's just one of these things that it's done for fun. You know, one thing I like to have kids see is that science doesn't have to be all boring and whatever. Sometimes it can just plain be exciting. So what I've got here is I've got a little bit of water, and I have some 99% isopropyl alcohol. Okay, so I think I bought it down at one of the local drugstores. You got to be careful. You can buy 70% isopropyl alcohol, rubbing alcohol, and you can buy 99%. I like the 99% because what I'm going to do is I'm going to mix it with an equal amount of water. Okay. And if you have 70% alcohol, the math gets a little trickier. You want to use less water. What you want to wind up with is about 50% isopropyl alcohol and 50% water. Now, it doesn't have to be isopropyl. You can be other forms of alcohol. It needs to be alcohol because you want it to be able to mix with the water, which alcohol does and gasoline does not. I would strongly advise you to stay away from methanol, however. Methyl alcohol. One of my favorite companies, Flynn Scientific, regularly goes on a rant against any idea of using methanol because they of course sell methanol, and they keep hearing back from places like elementary schools that had explosions from filling up the little lamps with methanol, and it just seems like a lot more trouble than it's worth. So if you're still using the alcohol lamps and things like this, probably should invest in a different way of doing things. Please think about that, because get on their website, type in methanol, and stand back, and they will tell you case after case after case where students and parents have sued school districts for problems involving methanol, and that's from elementary through college. So just isopropyl is a better, less volatile form. So anyway, so what we've done is we've mixed up the water here, and I happen to have some that I've already mixed up. And usually I do this with the dollar bill. I'll ask a student, I taught high school, remember, and if they wanted to volunteer $1, and usually, almost always there is someone, but this time I'm going to ump the ante a little bit, and I want to take a $20 bill, okay? Because that's the most I happen to have. I saw this the first time done in a National Science Teachers Association regional meeting, where somebody asked for someone to volunteer a $100 bill, and somebody did, and the guy was extremely nervous during the whole thing, worried that he was going to screw it up somehow. So you take this and put it down into the water and alcohol, and you don't necessarily tell the students it's water in there, because they can smell the alcohol. And when you put it into a fire, it will catch on fire. I used to do this with ethanol and water, and I'm a little more familiar with that. But the water is enough to keep the bill from catching on fire. So even though it caught on fire, and I'll do that again. Okay, so I will let this drip out a little bit here, and then catch it on fire. and I let it go a little too long. So if it does, it'll catch on fire, but as long as you don't burn too much of it, it's still, at the very least, you can take it down to the bank and say, I did it again. And they will take it and exchange it. It needs to be, I think, 60% of the bill still there. So anyway, as you can see, you know, from a previous one that I did, it worked pretty good. I would suggest that maybe perhaps you do it once and not again. And maybe perhaps a little bit more isopropyl than water. Okay? So again, just one of those fun things, and then you'll have to let the bills dry out overnight before you want to go ahead and put them back into your wallet. Okay? Thank you very much for watching. Goodbye.